What is a pattern? A pattern is a discernible regularity. All living organisms make use of patterns. The human immune system identifies patterns in pathogens to initiate an appropriate response. Sensory organs function as tools to detect patterns in the environment. A dictionary catalogs the patterns that a language and its users recognize. We find patterns in music and poetry. Mathematics is the study of patterns. Science rigorously documents patterns found in nature. If patterns are so essential across so many different human endeavors and to life itself, why is there no comprehensive philosophical treatise exploring what exactly a pattern is, how patterns are searched for, stored, and used? Why is there no general theory of patterns? Is it because the word pattern has been reduced to surface-level concepts like textile and design prints to mere decorations? Or is it because patterns are so universal that they are hard to notice without contrasting them to a universe where they are absent, like asking a deep-sea fish, "What is water?" Yet, in all discussions of intelligence, patterns are frequently mentioned without any in-depth examination of what exactly a pattern is. Patternism is the belief that patterns form the first principles for a complete theory of intelligence. All biological and intelligent phenomena can be reduced to questions about patterns. Without a theory of patterns, there can be no theory of intelligence. Any attempt to understand intelligence must begin with a fundamental understanding of patterns. All else will follow. A patternist definition of a pattern must be universal. It must cover not only everyday uses of the word pattern, but also applications across technical fields. This includes textile patterns, design prints, number sequences in mathematics, how a martial artist studies an opponent's patterns, how patterns are identified in machine learning, how neurons detect and store patterns, and even the phenomenon of reproduction. A patternist definition must be broad enough to cover all these examples. So, what is a pattern? A pattern is a discernible regularity. While there is complexity in what it means to be discernible and regular, this simple definition allows us to cover a wide range of phenomena. Reproduction, perception, prediction, deception, reasoning, and representation all rely on this basic concept of patterns. A pattern is made up of features. A feature is anything that can be used to separate two entities in a consistent manner. For example, color is a feature that allows us to differentiate ripe fruit from unripe fruit. Hair and mammary glands are features used to separate mammals from other organisms. Negative charge is a feature of electrons. Inertness is a feature of noble gases. Terms like properties, descriptions, and attributes are all similar to how we define a feature. Anything can be considered a feature as long as it maintains consistency in separating entities. Once the separation of entities occurs and features are defined, it immediately follows that features can be used to group entities together in a consistent manner. For example, we can group together all entities that share the feature of being the color blue. We can group all entities that have a specific gene. We can group all entities that have the features of having hair and producing milk. In effect, a feature is anything that can be used to both separate and group entities in a consistent manner. A pattern can be viewed as a collection of features. If enough features are detected, the recognition of the pattern is triggered. We can define a pattern as strict if recognition is triggered only when all features are detected. Conversely, a pattern is fuzzy when only some features need to be detected for recognition. Each feature can also have different weights in triggering recognition, and some may even have negative weights that inhibit recognition. Features themselves can be viewed as patterns if they maintain consistency in the separation of entities. From this interplay, recursive and hierarchical structures can emerge. Features can consist of subfeatures, and multiple features can combine to form a larger, overarching feature. Similarly, patterns can combine to form superpatterns, or be broken down into subpatterns. The key distinction between features and patterns is that a pattern is any discernible regularity, whereas a feature is defined by its ability to separate and group entities in a consistent manner. This separation and grouping of entities, essentially the formation of sets, subsets, and supersets, plays a fundamental role in many different phenomena. With patterns and features defined, we can now look at number sequences to illustrate how patterns function in mathematics. 2, 4, 6, 8, 10, 12 follows a pattern where the defining feature is that all numbers are even. 5, 10, 15, 20, 25 forms a sequence with the feature that each number is divisible by 5. 2, 3, 5, 7, 11, 13 consists of prime numbers characterized by the feature that their only factors are 1 in themselves. Given a set of numbers, we can define a feature shared by all members of the set. Knowing the features of a set allows us to predict and generate its members, as they follow a specific pattern. All mathematical formulas and equations work in the same manner. Every equation can be viewed as a collection of variables, a list of features, and their relationships to each other. If we view mathematics purely as symbolic manipulation, then the results of a series of manipulations will be strictly regular and consistent, making them patterns in themselves, provided the system of allowed manipulations remains consistent at each step. Textile prints and pattern design work in the same manner as number sequences. Once we identify the specific features of a design, such as the colors, shapes, and their arrangement, those features will repeat in space. As a result, if we know the features of a pattern design, we can predict and even paint and draw in the design that will appear in a given blank area of space farther away.